Okay, so we're going to do another kata here. I went through and just did some searches for 8 KU problems, and this one came up rock, paper, scissors. So, what it is this. Let's play. You have to return which player won. In case of draw, return draw. So, the input, there's an input 1 and an input 2. So, remember, we're always trying to figure out what are the inputs, what are the outputs. We all know rock, paper, scissors. But what is this rock, paper, scissors situation supposed to be? So we're taking in a player 1 and a player 2. So player 1 will be either rock, paper, or scissors, and then player 2 will be a rock, paper, or scissors. So these are the two inputs. So if you get scissors and paper, then it should say player 1 1. Because the scissors cuts the paper. Then this one, scissors, rock, it should say player 2 1 because the rock breaks the scissors. And then if it's paper and paper, then it's a draw. Okay, so you have two inputs, and then you have an output, which is a string. So one of the things that I personally have seen with a lot of people solving problems is that a lot of people think that a for loop will solve every problem. And in this particular case, a for loop is not the best tool for the job. Why? Because we don't have a collection of things that the output that we're giving back is just a string. So we're really looking for is just a hierarchical match. We're just matching stuff. Like, well, if the scissors goes with paper, then we know that then this one wins, and if the scissors goes with rock, then this one wins. So looping is only for when you have to go through an array of things, or you have to go through a string, usually, or even sometimes an object, and pull things out of it and then reconstruct something else. In this particular case, you wouldn't really need to loop. You need to be doing some comparisons using if statements, right? Okay, so let's just do our pseudocode. So the very first thing we need to do is since we know we're returning a string, we need to create our accumulator, right? And that is just going to be a string. We could just do our output equals an empty string. We know the output will be either player 1 1 or player 2 1 or draw. Okay. The other thing sometimes we do is take care of the edge case. In this case, if paper, right? So if they're both the same, then there should be a draw. So we'll just leave the pseudocode here. We won't put that there. And then the next thing we need to do is we need to compare. So we could say do comparisons and save the output in our output variable, in our accumulator or whatever. So in this case, it's even wrong to call it an accumulator. Actually, this is not an accumulator pattern. So we'll just say just create our return value. Why am I not calling it an accumulator? Because in this particular case, it's not accumulating, it's not building. We're not building it over time. We're just assigning it. So we take care of the edge case. If they're the same. And then we do a comparison and save the output in our output variable. Okay. And then last thing we need to do is return our output. Okay. So we did the return value. Now let's take care of the edge case if they're the same. So if P1 equals P2, then return output, returning draw, right? Draw exclamation point. Okay. Now the comparisons. So rock, paper, scissors. In this particular one, We know that if you have something like paper, I think that when you're trying to solve a problem like this, you have to ask yourself, okay, what are the possible combinations? And in this case, there's only one combination in which paper wins, and if it's going against um, rock, because paper gets eaten by the scissors. I mean, gets chewed up by the scissors. So since there's only one case in which each one of these win, then that means that there's a one-to-one pairing with what it wins against, right? So because and there's only three elements, but it's a very simple equation. It's almost like a matrix. So what data structure could we use to map out the winning, the winning matches? There's a one-to-one correspondence. If there's a one-to-one correspondence between a thing and then an associated thing, that is a JavaScript object, right? So we could say var or const, right? We could use const, right? Var or const, var win matrix equals, and you just put key. The key is the element, and then the value is what it wins against. So we could say paper wins against scissors. I mean, wins against rock, right? Scissors wins against paper, and rock wins against scissors. So this here is a key value pair of all of our winners. And then what we need to do is we just need to check. This is really testing kind of your use of objects, but this is a good test. We could say it's an if statement. We say if win matrix bracket P1. So what would win matrix P1 give us? So when you call the key, you get the value, right? So you call win matrix P1. If P1 is paper, you would get rock. That's the one it beats because paper covers rock. So if when you call the key, you get the value. So you call win matrix P1. If it were paper, it would give you rock. But if it were scissors, it would give you paper. And if you call rock, then it gives you scissors. So you would say basically if win matrix P1 equals P2, or triples equals whatever P2, right? Then we know player 1 1. Output equals player 1 1. Make sure we spell it right because this is, we're comparing strings here. Else output equals player 2 1. There's no tie because the draw is already taken care of up here. We can actually put this all in the same line just to save a little space. So I'm going to delete the comments mainly so we can get this all easier to read. So output equals empty string. Turn a draw if they're the same. Define a win matrix that maps out key value, key value, key value, and then call the key and see if it's equal to the value we want. So win matrix P1 equals P2, then player 1 1, else player 2 1, and then in the end we return output. That's our theory. Let's see if this works. Okay, that worked. Player 1 win and player 1 win a draw. So what I'm going to do is I'm going to refactor this. if you've never used ternary expressions before, please stop the video, turn it off, ignore this if you don't if this is already too much, or you feel like really satisfied with this being where you want to study and you want to do some examples like this. Don't feel obligated to watch the rest of this. This is just if you want to do some code shortening. So here we could use a ternary expression here. And if you haven't used ternaries and you want to learn, then please do continue watching. So when matrix equals, a ternary expression is basically it returns a value based on it's an if-else statement that's all in one line. So what you do is you put the expression that you're evaluating and then a question mark. And then the first answer, if the statement that you're evaluating is true. And then the second answer, here we'll just say output equals. Second answer follows a colon if the statement you're evaluating is false. So let's talk about that again. So output equals statement you're evaluating. If it's true, it jumps over the question mark to this, and that becomes whatever is assigned or returned here. But if this statement that's evaluated is false, then it goes over the colon. It jumps over all the way over the colon, and it returns this part. And so we return the output. So again, that's fine. And so we could actually then just return that and then get rid of this. And then we don't even have to declare value up there. So let's test this. All right, so let's attempt it. And it passed. So it was 3 lines of code. There are going to be people who solved it in 1 or 2. Submit it. Oh, yeah, other people did the same thing. They created an object. Rules equals, they called theirs rules. We called it win matrix. But see, theirs was longer. They didn't use a ternary. So we're actually shorter than them. Oh, these people are just mapping out all the, and you can totally do this, right? If you didn't want to use an object, this is a good solution. If P1 equals rock and P2 equals scissors, return that. Else if P1 equals scissors and P2 equals paper, return that. Else if P1 equals, so just do it if else is if else, if else. Completely legal. Completely legal. I should have actually done this should have done this as the first solution. This is what we call the brute force method. Just do everything. But you see, it didn't require a loop. So please don't use for loops for these types of problems. Oh, wow. That's interesting. They used a regular expression. That's very clever. Okay. All right, very good. So this is another solution here. We'll go over the next one in the next clip.